Yeah, so I'm going to talk about modules. If you want the slides, they're here. The link at the bottom. And so I'm going to talk about stories, future past. Anybody know the X-Men, Days of Future Past? Yes. All right, good. So if you don't, it's not critical. It's really just about there's a dystopia. You got to travel back in time, try to fix the things that went wrong. And so this talk is about modules, and you can think of the future being unevenly distributed. We sort of have module systems today. There's a little bit of there's some dystopia features about them, and maybe you can go back in time with standards and try to fix those things. Being a little melodramatic here, existing module systems are definitely usable today. Okay? There are some rough edges, and it'd be nice to be able to really use the same system everywhere. So hopefully that's what the standards will get to that point. And then hopefully along with the talk you can figure out how you can prepare yourself for the future. And there's some stuff at the end where it's not really about the module system itself, it's how you refer to things. If you know the two hardest problems in programming, one of them is naming things, and I think that's really just addressing them. So also, this is just my opinion. I'm not on TC39. I work at Mozilla, but I give feedback to the people that are working on the AnchorScript standard for modules, but I'm not an author. I just play in the AMD world, and so hopefully the idea is too, now with Node and AMD in the world, there's been enough sort of trial by fire in the real world, and we can feed that back into better standards. And so I'm mostly going to talk about AMD module systems. If AMD modules are the kind that you might use with require.js, Node is a common JS variant. And, but there are other ones, but I'm going to try to focus on these two because you probably encountered them by now. And so when you were talking about a module system, what are you really talking about? You got to be able to declare modules, reference them. When you have an ID for a module, you need to be able to normalize that. Then you want to take that ID and turn that into a URL. That's resolving it. You want to go fetch that URL. You might need to do some sort of translation work to make it into a form of JavaScript that the module system can consume. Then there's like a link and execute phase to actually bring the module into existence. And so when we're talking about declaring modules, if we look at the Node and AMD systems, today, the Node one at the top, maybe you can't see that. So require is the way that you grab dependencies, and you can either use the exports object to create named properties on that export object that other people can use, or probably more common, you'll see module.exports to just return a JavaScript value as the module value. And the same sort of thing works in AMD, except there's the function wrapper. That's there to get around some issues that you could encounter with eval or CORS security restrictions. CORS is cross-origin resource sharing. Just making HTTP calls to other domains other than your own, there's some security restrictions around that. So you can sort of paste the same code that you would use in Node inside an AMD module. I mean, at least on the surface, and it might look similar. With the AMD one, you can just return instead of using module.exports equals, and then in that case, you wouldn't necessarily need to do these. But the important thing is, while these look similar, there's actually a little bit of a difference under the hood. And so the main difference for Node, it's a very imperative style of dependency resolution. So it's not going to do anything until you hit a require call. Then at that point, it's going to go and do the fetching of the module and then executing it. And so for AMD, though, it's more of a declarative thing. If you've got the require calls, those are analyzed up front and then fetched, and then the factory function runs for the module. And when I talk about factory function, that's this function here. And so the consequences of this, node system, in the general sense, is not so great in the browser because you don't want to wait to hit a require call, and if the module's not immediately available, do some sort of synchronous I/O to go and fetch it. But you can definitely, like if you constrain the problem to bundling all the modules together and delivering that as a bundle, that totally works. If you have the same sort of needs as a sort of Rails asset pipeline sort of thing, where you just bundle everything up, you can get that with node systems today. And that's definitely a good chunk of problems. You can solve a lot of problems with that. But in the general case, that's a little bit of a problem. On the AMD side, because the dependencies are fetched and executed before running the factory function, it can make circular reference support a little bit trickier. You can do it, but it takes, you're more aware of the problem in an AMD system, where in Node, you can rely on function hoisting, and if you place the module that exports before your first require, you can get a little bit better circular dependency support, but even in those cases, you have to be aware of it. I mean, circular dependencies, you're likely going to notice them either way. And then, of course, with AMD, there's the function mapping, which ideally, you wouldn't have to have that. So when we're talking about module referencing too, there's also another difference between the Node and AMD systems. For Node, so there's basically two kinds of references. There's static references, and what do we mean by a static reference? It's something that if you give like a command line tool or a program the text of that file, it can just analyze by looking at the tokens to know what the dependencies are. A dynamic one here is something that might use like a variable, and so knowing what that value will be, you can't actually know that by statically analyzing the file. You have to run it. And for front-end systems, a common place where you'll see this sort of dynamic requires is like a URL or routing system where you have a bunch of views and you want to depend on a certain route, and then once that route is hit, you want to create that view or get that view at that time and then show it. For Node, since it's all synchronous, you can say, hey, whatever the value is, I'm just going to go and touch it rather than we hit the require. For AMD systems, recall that it's statically analyzing for these dependencies, so those are ready to go here. But if you need to do like a dynamic dependency, you're going to want to use a callback-based require to go and fetch that, because that could happen async. It may not be built into your bundle. And once you get into large enough apps sizes, it's actually a fairly common thing to see. There's some sort of router branch that'll use a dynamic require like this. So yeah, we talked about that synchronous thing is a little bit problematic in the browser, but you can definitely work around it. Like I said, there's ways if you can constrain yourself to those problems. That's great. But the AnchorScript system has to work well in multiple environments, and in particular the browser. So this is the way that they're currently thinking about doing it. Now, and recall too that this stuff is still under development. The AnchorScript committee is supposed to meet at the end of this month for a face-to-face meeting, and as part of that meeting, they're supposed to have a final sort of full draft that includes the module loader parts of the AnchorScript spec for modules, but then also the module syntax. And so the module syntax, they've kind of had that for a while now. You may have seen examples here where import is sort of like the require in the AMD Node systems. And the export is sort of like the module.exports equal or the export.y sort of setup, but they're using syntax instead, and they have to do like the module.exports equals in Node, or just to return the module value in AMD. They have this new construct. It's called export default, and then you return that value. And so the idea of it is, if somebody does an import, X from X, this sort of form gets the default export. If you're doing that sort of exports.y, like this sort of form where you have sort of named exports, you use these curly brace style. If you're familiar with object destructuring, it's a way to create multiple local variables off of object properties using sort of a condensed syntax. And so it looks a little bit like that. So that's why the curly brace is here. It's really grabbing. This is assuming lib was something that was written this over here. And then for the dynamic sort of calls, there's a system.import. And system is the sort of the runtime module API that's available in the AnchorScript system. So what are the properties with the AnchorScript system? So it's similar to AMD resolution, but it has no function wrapper. And so what do I mean by that? The import and exports, they have to be top level. You can't just nest them. It's not like a normal expression. There's top level statements in the module. And so what effectively happens is, those things are already available once your body of your module starts to run. So how do they solve the circular dependency issue? Import and export, actually, it's a new language construct. I've heard it referred to as a mutable slot. But what basically is sort of looking at a reference to a reference under the covers. But the idea is basically you can have your local import symbol, and even though when your module starts to run, that symbol may not have a resolved value yet, you can still refer to that later and have a handle on it. And later, after module initialization is run, if you reference that, you'll get the actual defined value. So they're being kind of sneaky, tricky under the covers there. But the end result is it has very robust cycle support. But because of that, and because it's a new language construct, that's why they're using import and export syntax. They can't use like a let or get because of this special mutable slot under the covers. And it's got a dynamic resolution that's an async style resolution. So we just talked about how do you declare a reference module. So now you get to how do I, if I have a module ID, how do we normalize that? Because all of these systems work on, you basically have a big hash map of IDs to module export values under the covers. And so it'll be common for Node and AMD systems, you can have relative dependency references. And Node is path-based, so it's based on wherever it finds the JS file, whereas AMD is module ID-based. So what does that mean? A/B can be found in a different place than A/B/C, based on the module, the configuration for the loader. And so it's a subtle difference, but it can sometimes be surprising from somebody who's switching systems. For the AnchorScript system, it's pluggable. That their module loader API has a hook for normalize, so if you want to do something really crazy, you can. It's hard to tell right now how the default resolution semantics would be, but I think it'll be module ID based, just because they're doing the ID normalization first, and then they go to the resolve step, which is resolving an ID to a path. So once we have a normalized ID, how are we going to translate that to a path or URL location? So Node, it uses nested multiple I/O lookups. So you have node modules and maybe nested node modules, and this is great because that allows them to avoid problems with version conflicts with dependencies. The trade-off with that is, you use more disk space. You might be loading more code into memory, but that's fine. Most of the stuff is fairly small compared to the server systems that are running them. So that's a good choice for Node. For AMD, since it's designed to operate over the network, it doesn't want to do multiple I/O lookups. So it's going to do, it has a default convention of base URL plus module ID plus .js. And then there's a declarative config. You can look at all the options there. But if you want to map an ID prefix to some other location, this is common if you want to load some things from a CDN, which you have some other things that are local. Declarative config allows you to do that. But between those two pieces, it results in one IL lookup per ID. For AnchorScript, it seems like they're going to go with the base URL plus module ID plus .js by default. But that's what they're trying to do is first just provide some primitives and allow JavaScript environments to customize to how they want to do it. So, and then there's a loader hook for this too. So for your own code, if you want to create a module loader that has some crazy resolve logic, you can do that. But then the idea is too is it sounds like they want browser makers, if they want to allow like a declarative config to make some of those things easier, which I think would make sense. That's up to the browser folks and their own standards committees to make that decision if they want. So we work on one of those, we know people that do that. I haven't looked at AMD declarative config. It doesn't necessarily have to be the same style, but the problems that it's solving are real problems because we've hit them in the real world, and that's why I believe it exists. So that'd be a good place to start. But okay, so then we've got our ID, we've normalized it, we resolved that ID to a path. We've got to go fetch it now. Node uses synchronous I/O. AMD uses async because it's usually over the network. And AnchorScript will be async by default, and the loader hook for you to override the fetch behavior is also it assumes async. There's a callback mechanism for it. And so even though the fetching is async, that doesn't mean that fetching for those dependencies has to be expressed, in an async manner. If we go back here, you notice you don't have to do, like a parentheses function callback here. That style of fetching would work also at Node. You just have to, fetch the stuff up front and then evaluate. But there's enough loader hooks that Node will be able to, retrofit their current behavior into it. And so then there's a translate step. So for normal JavaScript modules, there's really not much of a translation step. It's just JavaScript. But you could have some things like CoffeeScript or some other, transpile language. And so the AnchorScript system wants to allow for that. The existing systems have some mechanism for this. For Node, you can require this, special module. And then there's this underscore extensions, and then you give it the extension that you want to be able to process, and you give it a function. So basically, your function gets a shot at converting any text that's found at that extension. AMD loaders, they have this concept of loader plugins. And so if you'll have module references that look like this, like text bang a.html. So what this means is the text is just another module, but it implements specific loader hooks. And so when the loader sees, the general module loader sees this ID, it says, okay, I'm going to load text.js first. And I'm going to ask it, hey, do you want a chance to normalize this? They don't have to. They can use the default normalization. But then the other hook is load in the AMD system. And then they go and load that resource. And so I like this model better because like if you have the type of dependency that is only like a one-to-one match with the file extension, those still work here. You're just specifying the extension first. But this also opens it up so that you can use the same resource multiple different ways. So what do I mean by that? That here you can imagine you might have a system that wants to show the text of each HTML template that you're going to use for a view. but then you also might have that template, you want that to actually function as a function where you give it data and then it returns a string of HTML that was bound in that data. In this model, you could have those both operating in the same module system. For AnchorScript systems, it's an imperative loader hook, so it's similar to the other hooks for normalize, resolve, and fetch is a translate one. They don't want to go with formalizing sort of like a separator and formalizing this behavior. They still want to, there's big enough work for them that they want to start with the more imperative primitives and then allow the communities to bootstrap from that, and then on maybe ECMAScript 7, then they can go back and if there's common enough practices, then they can merge those more declarative things into the ECMAScript specs. And so then there's the link and execute stage. So like once we've translated, we got JavaScript, we want to execute, and we got to run it. For Node and AMD, it's really just normal JS evaluation. AMD may do that via script tag, but it's just normal JS evaluation stuff. ECMAScript, it's a little bit more tricky. There's a linking stage because it's import-export, mutable slot things, and because it's syntax, they can actually check if it's the named exports. They can check those against the named imports to make sure that those are valid. So you can get one level of static check in there, but then they eval. But for practical use, you won't have to worry about that too much. It's just knowing that import and export are the mutable slots. And so, if you're using an existing module system, how is that going to translate to the new world? So I expect Node will use the ECMAScript module loader hooks to wire in their existing behavior. So it's not like you have to take a big hit to convert all modules to this new syntax. The ECMAScript is trying to make it configurable enough, there's enough loader hooks so that they could support their system. For AMD, I think it's likely that we might just have a small scripting to do the loader plugin style syntax, because that declarative syntax makes the most sense. And let's go on. But we'll have to provide that for now, and probably an adapter for the old API. But hopefully, if browsers come up with a good declarative config, there won't be enough. You won't have to provide declarative config for sort of AMD adapters, unless you want to just reuse your old config. So one sort of gray area that's still a little bit funky for me for ECMAScript modules for bundling to the client. Since import and export are these new constructs, it's still a little bit gray on how they want that to work in the bundle. There's been a proposal to do like a loader.define and give a string of the module so that they don't have to worry or work out the inline module syntax. But that part, we'll have to see how that comes out for November. But for normal developers, though, like what do we want to work on now? Like what can we do now without having to write for ECMAScript? You can use like an ECMAScript transpiler if you like. For me, I'm not too keen on that. I'd like to see the ECMAScript stuff settle a little bit more. And right now, the transpilers just help with the module syntax of declare. It doesn't really give you anything to load modules. That's what the module loader API is about. So I'd like that to come along a little further. But what we can start to do now, because we've seen this in AMD usage, a lot of different front-end projects have a lot of different patterns on how they write their files. If we get into the habit of using base URL plus module ID plus .js, that's going to carry forward pretty well. And so I think if we start to think of project layouts that fit that sort of goal, I think that's something we should start looking at. And I'd like to have sort of better front-end package managers for this. NPM could also adapt to this if they wanted to, but for Node itself, since they're doing multiple IO lookups anyway, they don't necessarily have to. But for the front end, I think it's more important, and I think that's where the diversity of style is more in play, and I think that's what makes it a little bit harder than to share best practices across people that are using like AMD systems now, because everybody has their own sort of custom config on how they like to think things out. But, if you're a package manager, or what your friend is, I think one of the things with this is to realize that runtime use is the most important use for the code, not the package manager's use. To support like a base URL, module ID, JS thing, a package manager might have to do like a couple more checks, but they have the bandwidth and file access to be able to do that. Whereas systems that are sort of running in the browser, they don't have that luxury. So I'd like to see that sort of shift over more for that. And if they need metadata, there's the package JSON for the app itself, or they can create a metadata to store some of that. And I think for front-end projects then too, particularly at the app level, I think there's also a style of thinking in the Node community for this too. Front-end code doesn't normally need sort of compiled extensions like Node does. And so it's a lot easier for us for front-end projects to just check in our dependencies with the app project. That also simplifies deployment later. We don't have to depend on another network service for installed code. And if you're worried about packages, well, what if I have a directory that has maybe a couple of JS modules and maybe some CSS? Those are still supportable if the package manager writes out an adapter module at this location. So like if it was installing a package X, and inside of X there was a main.js and a main CSS, for example. If the package manager writes out a file at base URL plus x.js with its content, then it'll work without any other extra configuration. And so if you're curious about what an app layout like that might look, particularly if you're using an AMD system, this is sort of a sample project that has that sort of layout. And then Volo is a package manager that I did that works with GitHub as the registry. I don't necessarily want everybody to use Volo, but it does demonstrate the base URL practices, and if it's just a single file JS file, I think that's also something where just that JS file should be installed, not the whole directory. So it demonstrates those approaches. So if you want to encourage your favorite package manager to do the same, there's some pointers in here. And then this is also some library best practices if you're curious about how you might want to structure libraries to fit into that world. So yeah, so that's it. If you have questions.